Bismillahirrahmanirrahim and Assalamu alaikum. As we have already discussed the modern periodic table, and we know that in modern periodic table the elements are arranged according to their increased atomic number, and elements in same group will have almost same chemical properties. Now these properties, whether they are physical or chemical, whether the metallic character or non-metallic character, is repeated after an interval. For example, let we have the elements belongs to second period of the periodic table: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. While in the third period there is sodium. So starting from lithium, after an interval of 8, the next element, which is sodium, will have almost similar chemical properties to lithium. So this repetition of properties in groups and period in periodic table is called periodicity of properties. Let we say that lithium is metallic, therefore sodium is also have metallic character. These repeating properties, which are called periodic properties, are atomic size, ionization energy, electron affinity, electronegativity, and shielding effect. We will have to study all these periodic properties one by one. Now, first of all, we have to start from atomic radius. We know that atom is not rigidly, the size of an atom is not rigidly fixed. The size of atom in different molecules is different. It means that the size of an atom is affected by the size by the other atom when it is in combination. So the distance from the nucleus to the outermost shell of an isolated gaseous atom is called atomic radius. And as we know that atom is always in combination with other element. So when an atom is in combination with other atoms, the size is affected by the neighbor atom. Sometimes the size of an atom decrease when it is in combination with certain atom, while in other cases that size increases. So the size of an atom is not rigidly fixed. It depends upon the neighbor atom with which it is bonded together. By the definition, the average distance from the nucleus to the valence shell of an isolated gaseous atom is called atomic size. And as atom is always in combination with the atom of some other element, therefore we cannot take an isolated atom. So instead of taking atomic size, we will have to discuss the radii of the atom, whether it is in combination with the atom of its own element or it is in combination with the atom of other element. So atomic size is expressed in atomic radii, covalent radii, and ionic radii. The reason why we are discussing in atomic radii instead of atomic size, look, the size of an atom is not fixed when it is in combination with other atom. Therefore, the size of an atom is affected by a nearby atom. An isolated atom has different size than when it is in combination. Depending upon the nature of combination, atomic size is expressed in terms of atomic radii, ionic radii, and covalent radii. As we know that atom is a very small particle and we cannot take a single atom. Secondly, atom is a very reactive unit of an element. Therefore, it is always in combination with the other. So when an atom is in combination with the other atom forming covalent bond, then we will have to discuss the covalent radii. If it is in combination with the other atom forming ionic bond, then it is said to be the ionic radii. So let me start from atomic radii. The distance from the nucleus to the valence shell of an isolated gaseous atom is called atomic radius, and it is represented by R. Let's suppose this is an atom This is the nucleus of the atom, so the distance from the nucleus to the valence shell is said to be the atomic radius. As atomic radius is the distance from the nucleus to the valence shell, so we will have to take the unit of length. And as atom is very small particle, so the unit of length used for the radius of an atom is in nanometer, which is equal to 1 into 10 power minus 9 meter, or it is picometer, which is 1 into 10 power minus 12 picometer. Now, what is the trend of atomic radius in periodic table? By trend, we mean that what happens to atomic radius when we move from top to bottom in a particular group or from left to right in a period. Generally speaking, in groups from top to bottom, the atomic radius gradually increases, while in period from left to right, atomic radius gradually decreases. There are so many factors. The most important factor that if you look at this table, in a group as we move from top to bottom, in each successive period, one electronic shell being added into the successive element. For example, there is only one electronic shell in hydrogen, there are two electronic shells in lithium, and there are three electronic shells in sodium. So as we move from top to bottom, the number of shells goes on increasing. The distance from the nucleus to the valence shell gradually increases, and we will say that atomic radius gradually decreases. Suppose this is the atom. For hydrogen, there is only one electronic shell. For lithium, there are two electronic shells. For sodium, there are three electronic shells. And as we move from towards the bottom, the number of electronic shells gradually increases. So in hydrogen, there is a distance from the nucleus to the first shell. In lithium, this is the distance from the nucleus to the second shell, while in sodium, it is the distance from the nucleus to the third shell. So as we move from top to bottom, the number of electronic shells goes on increasing, and therefore atomic radius increases. In left to right, we say that atomic radius gradually decreases. We know that elements belongs to same period will have same number of electronic shells. In sodium, magnesium, aluminium, and all of the rest element of the same period will have same electronic shell. In sodium, 11 proton attract the third shell. In magnesium, 12 proton attract the third, while in aluminium, 13 proton attract the third shell. Obviously, the attractive force on the third shell increase gradually as the atomic number goes on increasing. There are 17 proton in chlorine which attract the valence shell more towards itself. As a result, the atom will shrink and the size of atom gradually decreases. So we can say that the atomic radius in periodic table increase when we move from top to bottom in a particular group, and it decrease from left to right when we move from left to right in periodic table in a period, it decreases. So it is all about the atomic radius. Goodbye and have a nice day. Thank you.